Alright, so now we're going to go over the class activity. There were three problems on probability, mainly on conditional probability, right? So we are going to go over those questions. So if you haven't completed the questions yet, or if you haven't tried reading the questions yet, just try solving the problems. If you're stuck on it, give it a minute or two, think about it, and if you can't do it, if you can still do it, just come back to it and you'll see the explanation part here, right? So let's jump right on it. Okay, so it says a urn A contains six white and six white and three blue, right? Urn B has 18 white and 36 blue chips. A man selects an urn at random and draws a chip. What is the probability that it is a white chip? Okay, so it's saying that there. Okay, let me draw the diagram. Urn A and B, 6 white here, 3 blue here, 18 white and 36 blue here. Okay, and these two urns are selected at random, so each one has 50% chance of being chosen. Alright, and we're looking for a probability that it will be a white chip. So it could either be from urn A or B, correct? So we can say that A is event A is choosing urn A, B is choosing urn B, and W will be choosing a white chip. Okay, so W P of W, probability of W equals probability of A and W plus probability of B and W, because we have two different cases in your A or your B, and this can be rewritten as probability of A times probability of W given A. Okay, and this one, it can be rewritten as probability of B times probability of W given B. Okay, and we established that probability of A being chosen is 1/2, because these two are equally likely, and probability of W given A, so probability of choosing white in A, right? That's 6 out of 9. And here, probability of B is always the same, and probability of choosing white in your B, that's 18 out of 54, right? So this is 2/3 that cancels out, comes out to be 1/3. This is 1/3 plus 1/6 equals 1/2. So this is the answer to right. Okay, sorry. Okay, so let's move on to part B. It's pretty much the same thing, right? Now we're just going to add another event, which is let's just write it as BL, right? This is choosing a blue chip. Okay, and probability of BL is probability of A and BL plus probability of B and BL, right? Again, we can rewrite this as using the Bayes theorem. So this is going to be probability of A and times probability of choosing blue given that we're in urn A, probability of B times probability of blue given that we're in urn B. Okay, so probability of A is always 1/2. Probability of choosing blue out of in urn A, that's going to be 3 out of 9, plus probability of choosing B is 1/2. Probability of choosing blue in urn B is 36 out of 54. So that comes out to be 1/6. And what is this? This is 2/3 plus 1/3. Okay, so this is again 1/2. Right? So that concludes number 1. And let's now move on to number 2. Okay, a basketball coach decided to be fair. Okay, from a group of 20 applicants, 10 short, 5 medium, and 5 tall, he decided to choose his team of 5 players at random. Find the probability that among the 5 players there are 5 tall players. Okay, so this, let's just write T equals T, let's say T sub I equals ith pick is tall, right? So what we're looking for here is this T1, T2 intersection of all these events, right? And this, again, using Bayes' theorem, can be rewritten as probability of T1 times probability of T2 right, given T1 times probability of T3 given T1 and T2, right? Probability of T4 given T1, 2, 3, and lastly probability of T5 given that these all happen, right? It makes more sense in words than in formulas, so let me just talk about this in words. Okay, so let's just give it a more. Okay, so what it's saying is we're first going to pick, okay, we're first going to pick a player, a tall player, right? So what is the probability of choosing a tall player? So we have 20 applicants and 5 of them are tall. So this is the first pick, okay, is tall. Times, now that we've chosen the first pick as a tall, now we have 19 candidates. And how many tall people do we have? We have, well, we chose 1 already, so we only have 4 left. So this is the second trial, and so on and so forth. Now that we chose 2 tall players, we're going to have 18 of them, and we only have 3 tall people left. And now that we chose 3 tall people, we only have 17 left with 2, and lastly 16, right? So if you cancel this out and simplify this, you get 1 over 15504. So this is the answer. Okay, now it says here we have 4 tall and 1 medium. Okay, so this is probability of 4 tall. Let me not write this. This is 4 tall and 1 medium, right? But just think about this. This means that your first pick might be medium, or second pick might be medium, or third pick might be medium, so on and so forth, or the last is medium. Alright, so just thinking about that, let's just assume that we have the first one is a medium, right? Then we would have 5 over 20, and then we would have 19 of them left, but we still have 5 tall people, right? This is 18 and 4, 17 and 3, 16 and 2, right? So this is when the first is medium. Now let's look at the second case, when the second one is medium, right? So say the first is tall, so 5 out of 20, and the second is medium. So second, how many mediums do we have? We have 5, and now that we've chosen one person, we only have 19 left. And then now we're picking the second tall, and now so we've already chosen another tall people, so it's going to be 4 out of 18, and then 3 out of 17, 2 out of 16. So if you look at this, these two are identical, right? These two are identical. So what we're going to do here is we're going to use one of these. So we'll say we use this formula, but we just have different options. We just have 5 options to place the medium. It could be first, second, third, fourth, or the fifth. So we're going to multiply this by 5 because we have 5 different options, right? So we're going to multiply everything by 5. Okay, and the denominator is the same. Okay, this is causing a little trouble right now. Let's just fix this. Okay, so everything else stays the same. The denominator is the same, but it's just a numerator that's being changed. So it's not listening to me. Okay. Okay, let's hope that it works now. This is taking way too long. Okay. So that's 25 out of whatever we had before, 15504. Okay. And last question. A certain school gathering has 40 freshmen, of which 25 are under 21, 50 sophomores, of which 30 are under 21, 60 juniors, 30 under 21, and 20 seniors, 10 under 21. A student is picked at random and found to be under 21. Right? And what is the probability that he is a senior? So let's assign some events. You can say that S equals the student is a senior. Okay? And say that T is under 21. So pretty much a student is picked at a random and found to be under 21. So we already know that it's under 21. So we're going to use that as the given. And what's the probability that he is a senior? So it's what is the probability that he's a senior given that he is under 21? Okay? And this is what we learned before. This is ST over probability of T. Okay, so what's S and T? Well, it says 20 seniors and 10 are under 21, right? So it says right here. So we're going to have 10 people. Actually, we're not using probability, but we're just counting numbers because these are out of the same number. The bases are the same. And probability of T, which means that probability of people under 21, well, for freshmen there are 25 of them, so that's 25. For sophomores there are 30 of them, so that's 30. And juniors there are 30 of them as well. And seniors there are 10 of them. Okay? So if you multiply that out, that's going to be, what is this? 1695. Okay. So this is actually not 100. Yeah. So this should be the answer. Okay. So that was it for the class activity review. So jot down any problems or questions that you have for Q&A session. And also review through this and also the review through this and the previous lesson that you haven't caught up with. Okay, so that's it for today.